Welcome back, guys. I know it's been a long time, but I have some no good news, but maybe one good news, but the rest is pretty bad news. Anyway, I will explain what happened since the last video. In the last video, we made the new battery pack for the electric turbo, and it's great. It's super powerful, and I've been able to test it a little bit, but not for so long. I achieved around 7 psi of boost with the electric turbo or the electric supercharger for a couple of days till something happened, and I think it's the motor. I'm pretty sure it's the motor, but maybe the ESC, but we'll find out later, maybe later in the video or maybe in the next video, to see if the ESC is in good shape or not. So maybe you wondering what happened with the motor. Honestly, I really don't know, because all look fine. I tried to probe each lead and all look good, I think. The resistance is pretty low, so I'm not been able to measure if there was a short in the coil, but maybe was the case. I will explain a little bit later. But I disassembled all of this, and the thing make me the more frustrated about is this TP motor was supposed to be a TB 4070 CM series. The CM series is pretty important because that was a motor I needed and I want, and the motor I bought. But when I disassemble it, I see this Kevlar wrap around the rotor, and that's no good because the CM series have a stainless sleeve. So this was my first concern about it. It's pretty bad because I threw a lot of current, a lot more than even the CM series can take. So knowing that is normal series, it's sure I'm pretty sure it blow up. The max voltage for the CM series was, I think, 32 volt, and I threw around 50 volt in it. The max power and the power rated is around I think it's 12,000 watts in peak, and I achieve around 17,000 watts in this motor. So the normal series, I don't remember the spec, but the spec is way less than the CM series that I was supposed to have. So this is pretty bad. I had good result for this normal motor. I'm pretty sure with a new one I will achieve a way much better result. Talking of a new motor, this is my new Castle motor, 1721, I think. It's the 4-pole motor, 90,000 RPM, 2,400 kilovolts, kV, sorry. So this is the new motor I will try, but to try it I need to make a new shaft like this. It's pretty much the same shaft I will put in this, but this one have a flat spot on it, so I will try to make some things different with this, and the technique I use for this I will change it too. I will explain to you what I will do. But beside the motor, I bought a new Impeller wheel. The main reason why I bought a new Impeller wheel is because the last one, it's for something maybe. I will try to explain what I think it is, what happened. But the last Impeller wheel, I had contact, a little bit of contact here, but not that much, but enough to worry about and to change the Impeller wheel. So maybe the first reason why is, yes, I bought a Chinese turbo. It was cheap. The last Impeller wheel was casted, so I think it's less strong than a billet one. So I think the fan, maybe with the torque of the motor, maybe the fan, I don't know if, do you call the fan, the blade of the wheel, maybe flex just a little bit, because I have pretty much no clearance between all the thing. I don't know what the gap should be, but I think I left 15,000 of an inch between the wheel and the compressor. So if the blade flex a little bit, maybe it could touch the compressor housing. But the other thing is the shaft. I try my best to make a perfect shaft. The shaft go on top of the motor shaft, so I have room for error. And when I measured it, I had 5/10 of a thousand. Yes, maybe it's too much, I don't know, but I will try a new method. I will try a new method to make the shaft and make it true and perfectly concentric, and try some new tricks. The last one, I slid in on and put some glue to fix it, and so far so good, this worked. But maybe the glue and everything make the shaft a little bit off-centric with the small slight fit I have. Maybe another 5/10 of a thousand, so we are 1,000 of uncentered. So with all of this and all the piece I have, maybe that was enough to have contact with the compressor wheel, the compressor housing, sorry. So I will explain the tricks I will do with the lathe and all my machining process. So I make a drawing for maybe a better understanding. So this is the chuck of the lathe, and this is the point I use to center my my workpiece, and be sure, if you have a long piece, you need a point to secure it, so the piece will not flex and fly away. So the point is, must have to make this thing, this kind of thing. So imagine this is my motor shaft, the same as the last one. So you have the hole for the motor shaft that goes in there, and the next step is for the bearing in the housing right there. The long shaft is for the impeller, and the thread is obviously for the nut. So the problem here last time was, if I make this piece one piece like I made last one, all of this is perfectly concentric and perfectly straight, no problem with that. Even if you think of it, even if the point is off center, when you're gonna machine it, it's gonna be all through, all the piece will not wobble around. The only thing that will do is make a taper shaft, so maybe you will have 1000 or 2 bigger here or here, whatever. So you need to pay attention of this, and most of the time the point is not perfectly centered. It always have some misalignment, so this is not a big problem. The other thing is, when I made my shaft, I made my hole in the second operation. So when I flip it over, the chuck, I try to take my piece in the chuck and align it. I have my my probe, and this wobble a little bit, like 1000 or 2. So I've tried to adjust it, and the best I can get is 5/10 of 1000. But even if I try to make it straight as possible, maybe the shaft was a little bit like this too. So even if the piece is very off-centered and you probe here, maybe you will have a perfectly concentric shaft, but if you probe there, it will wobble, because if you imagine this axe line go straight right there, and you probe right around there, it will be perfectly centered. Your probe will not move at all. So this is another problem. So 2 in 1. So this time I will make the hole first, then make the piece on the other way. So even with the point in there, even if the point is off center, like I said earlier, the hole will turn automatically through with the point. So even if this jump a little bit, I will machine it straight, so I will know the hole is perfectly straight to the rest of my machining. But there I need to use a left hand tool for all the shaft. So this is a little problem, because I don't work with left hand tool that often. So but it's pretty much the same thing. It's the same feed and speed and the right one, so this is not a big problem. So this is how I'm gonna do this. And for the hole, yes, I remember when I said this one I slide in on and glue it to the motor shaft, but this time I will try to make it precise. Last time I made it the most precise that I can, but now I found a new trick for the hole to be maybe a shrink fit, but I'm not sure with the shrink fit yet because of the flat spot on the shaft. So maybe a really tight fit, maybe just a little bit of heat on the shaft to slide on the motor shaft, but that's it. Maybe not a big shrink fit, just a little bit. And I will put the set screw there, and have a ball mill to make a little dent in the shaft and thread the set screw in. Anyway, I will try my best to make something good. And for the motor, I will machine all the housing of the motor and put a big custom heatsink on it. So this will give me some some chance on my side. Maybe this I don't need to remake it because it slide right on, and I'm pretty sure the bolt cycle is the same of the last motor. So I will try something with this. So now the sketchy part is remove all of this like a heatsink, factory heatsink on the motor. So I made a plastic piece in the point in the chuck, and that's scary a little bit. I try this. I'm done with turning the motor and the heatsink as well. The heatsink goes on top of it, and I screwed it on both sides. I'm gonna put thermal paste inside between the motor and the heatsink, so the heatsink can do his job perfectly. I decided to grind my little spacers because I realized that I have 2000 of not parallel, so I put it on the grinder to make it perfectly flat and again to maximize my precision. The trick here to get a super precise hole on a lathe, when you have a little hole like this, sometimes you can use a boring bar or some reamer, but when you need a super specific measure, sometimes you can't use the reamer because you need to butt it undersize, and it always rim oversized. Anyway, big mess. If you use a boring bar, like you see, this is small, but it's way too big for a hole. So what I use is an end mill. You drill close to your measure, and you use a hand mill and you put it on your tool post, and you use only 1/10 of the hand mill. So you go like this. Focus, please. You go like this in little angle. Put the hand mill in little angle and use only 1/2 of the hand mill to bore your hole. So like this, you can be precise to the 10th of a thousand. Now the tricky part. Let's see how much time it takes to make the shaft. Almost 2 hours later, I finally have my shaft. I think it's good. Gonna proceed to the next step is to drill 2 holes for the set screw, and after that we'll try to fit it on the motor. Well, yesterday when I finished all the part, I've tried to set the shaft on the motor. So I heat up the shaft for my shrink fit that I tell you, but all goes really wrong. So I don't really know what I'm gonna do with this, but I mounted on the lathe. As you can see, the shaft don't go all the way, and the set screw is not even aligned. So I'm screwed with that, but I want to know how much this jump. So I set my indicator there, and it jumped a little bit, but not that much. considering all this long is about less than 2000, so I think it's pretty good. I'm not really sure, but 2000 is pretty good. I'm gonna see on my bearing where my bearing go, if it jumped the same. If it jumped the same there, I'm pretty sure I'm set, but I think I'm gonna stick with that and just make a shim spacer for this bit of the shaft. Don't go in it. So yes, I will try something. So yes, it's the same thing here, like 2000, and I'm curious the motor shaft. I will try to indicate the little space I have here and see how much it jumps. So I think my theory of making the shaft on the other side, it's not as perfect as I thought, because as you can see, the motor shaft don't have a play in it, don't jump. So the problem this is gonna cause is, since my shaft is gonna be on the bearing there, the motor bearing will have the stress of the 2000 jumping. Is this an issue? I really don't know. I'm not sure. It's less than a 2000, so maybe it's not that much. I know it's not that much, but in the eyes of a machinist, this is a lot. But 2000, I'm really not sure, because if I try to remake the shaft, it's gonna be another 2 hours, and I need to cut this one because now it's fused to the motor shaft. So I need to trim this, but there's a chance I scratch the motor shaft and blah blah blah, all the bad thing. So I think I'm gonna leave this there. So the impeller, I'm pretty sure the impeller will not have a problem about jumping. 2000 again, it's not that much, and for a setup of more than one piece, it's normal to have some lack of precision. That's totally normal. The shaft should be made on the grinder, and sure, it's need to be made in one setup. But now I have 2 setup, and I have no other choice than 2 setup. So I can't make it in one setup. It's just not possible. So this is my problem here. The spacer should be right there, but since the shaft is not all the way in, I have this much space. So instead of trying my best to measure this shoulder to this surface, I will take advantage of my indicator and my readout. So I'm gonna probe the shoulder and this surface, and it will give me precise measurement. So I'm going close here. Let me set up this a little bit better. Well, bad news. The ball is too big to fit the little shoulder right there. Focus, please. Anyway, the little ball is too big for the shoulder, so I can't measure it. So I have a genius idea to put this edge finder. This is a light so when it's ground to something, it light up. But after that, I thought, yes, but this is the motor shaft, and this is not ground. Anyway, the light don't glow, so maybe I will try to take my lathe tool, just touch there and touch there. It's gonna be better than nothing, but yes, I really don't know. So this is what I'm gonna do. I'm gonna take my tool, touch the shoulder, put my readout to 0, then come back again and touch the back of the motor and subtract my my thickness of my spacer. So I'm gonna have a number, and I'm gonna make a shim that's precise to the number. So I have my magic number, and it is 1 inch 2 and 12, and my shim was already 1 inch and 22,000. So I need to make a shim, another shim of 1 and 90,000. So I'm gonna make this and going from there. I'm done with the part. It's pretty cool because I can reuse my old spacer, my old backplate, and everything. So the motor will stay like this. I'm gonna take my first spacer, put it there, screw this. After this, I'm gonna mount my new spacer for my because of my shaft, and screw my back plate on the other side with screws. All the part is put back together. I can't wait to try this, but first I'm gonna program the ESC for the new motor, the new battery, and new everything. So I'm gonna do this off camera, and I will maybe put in the next video how it perform. I just realized I can't say this word correctly in English. But anyway, the tuning of the car, it's not completely done because I never had the chance to try it super safely before it blow. So yes, next video I'm gonna show you all of this, and yes, thanks for watching. Bad news, testing the new electric motor. I'm pretty sure it's the ESC problem and not the old motor problem. Maybe the ESC have something because of the last motor, but I'm not sure. I will show you. Like right there is last year test. As you can see, each division is 200 milliseconds. But look at the curve. The bottom one is this is the peak current. Right there we saw 327 amps, and the max is 335 amps. So this is pretty good. The peak it's not that much, but when we look the new log, the new historic chart, this is where we found problem. The exact same thing happened with the new motor. I press the pedal, it goes up and it shut down after second and a half, and this is 30% power, and we see a peak of almost 900 amps. This is a problem. The old motor, I was able to run it to 350 easily without problem, but this is a brand new motor. I dropped the voltage to the spec factory, and this is keep happening. So I try to lower again the power. Right there I'm at 20%, and I was able to keep it running, but look at the amps. It's not possible. 520 amps for something I was able to run at 300 amps, and way powerful than this. And we look at the RPM, and we are barely at 30,000 RPM. Seriously, this is weird. And if we look again the segment of 100 millisecond, you see spikes of more than 100 amp right there. For 100 millisecond, 100 amp right there, goes back up, goes back down, goes back up, goes back down. And when it works, it jumped for maybe 20 amps, and now it's more like 100 amps. So I will contact MGM, and if you know something about it, please let me know. For sure my ESC have something, but it it don't blow and fire in my car, so this is a good news. Yes, sad thing, but this is what happened. Now for real, thanks for watching. I will be back when my ESC will be repaired, and all the thing will work fine. It's sad because it's almost the end of the summer, so maybe not this year again, maybe next year. I'm tired of it. Bye bye.